Well, congratulations. You made it to calculus. Hope you had a great spring break. Hope you are refreshed and ready to take on these last couple months of the school year and finish strong. It's really important to finish strong. I know it's hard this time of year. It's like the weather starts getting better. We start thinking, wow, this is I can sense that the summer is approaching here, and sometimes though students kind of back off a little bit really when it's time to really buckle down and make sure you finish strong in your classes, and don't back off now. You can rest over the summer, and we can work hard over these next couple months, and that's what we will be doing. We'll be working hard learning about calculus. And I wanted to just start off with the definition of calculus. Some of you may have quite an understanding of what calculus is, but maybe not a clear understanding. So I want to just make it really, really simple. Calculus is just the study of change. If we can kind of boil it down to a really simple definition, of course there's lots of things that calculus is, but really it's the study of things, how things change. And you've really studied how things change before, but in the context of calculus, there will be some things that you learn how to do that you never would have been able to do before, which is kind of cool. And what I really love about calculus, and I'll kind of get going here with the lesson here in a second, but what I really love about calculus is that you finally get to really you don't have to do a lot of work, but it takes a lot of knowledge to understand how to do the problems. And so what it boils down to is there's a lot more thinking involved in calculus than just like pencil and paper. It doesn't take a half a page to do a problem typically. Sometimes they do, but most of the problems are just kind of look at something and then write down the answer. And that's the cool thing, is that it takes a lot of thought and a lot of analyzing, and that's where it gets really fun, because your brain starts working maybe harder than it's worked before, and that's a good thing, because you'll really stimulate some brain activity in there, and it's just it's really exciting. So I hope you start embracing calculus, and you don't kind of cross your arms and think, this is just too much for me, I don't want to do it, I don't want to try. It's really rewarding, because when you have to think a lot and you get it right and you finally understand it, it really is really self-satisfying. So I wanted to encourage you to keep an open mind, and let's go ahead and get going here. So calculus being the study of change, over the next couple months we're going to be studying limits, derivatives, and integrals. And today, though, I'm going to introduce you to what the concept of a limit is, and in fact, specifically, though, we're going to find limits using tables on the calculator, so have your calculator ready as well, and finding limits conceptually by looking at the graph of a function and asking ourselves, what is a limit, or what is the limit of that function? And so, anyway, let's go ahead and get started. As you can see, we're in section 14.1, but let me get rid of a couple things here. In fact, I'm going to pause it just real quick while I get rid of some stuff. So you're going to see some changes here in just a moment. Hopefully that picks up where we left off. All right. So notice here that the graph of f of x is shown in yellow. So the yellow curve represents y equals f of x. And as you notice, if you do notice this, if you just want to find what is f of c. Okay, so c happens to be this value down here. It's a random value along the x-axis. It's just a real number along, like I said, the x-axis. And so f of c, you should know what the answer to this is, because this is algebra. So I'll give you a second, or I'm going to write the word algebra up here. So algebra, so we're not doing calculus yet, but algebra is f of c. What is f of c? Well, you plug c in, and what comes out? Well, what comes out is the y value right there, n. All right, fine. Well, what is calculus then? Well, the calculus part of this is this. When you see LIM, that's short for limit, and we say the limit of f of x as x approaches c. Okay, so this is totally different than anything you've seen before. So the limit of f of x as x approaches c, and I'll write that down as well. Read the limit of f of x as x approaches, I'm going to have to abbreviate approaches, c. Okay, so that's approaches right there. Okay, equals, and sometimes calculus is the same as algebra. In other words, the answer to the calculus question is the same as the answer to the algebra question, and in fact, this is the same. Okay, so I want you to understand what that means. It says, basically, and I'm going to do this, show you along the x-axis here, as x is getting closer and closer to this value c, then the question is, are the y values getting closer and closer to one real number? And in fact, as you follow along the curve, okay, so as x is approaching c, let's say from the right hand side, this guy right here, okay, then you're right along this curve, okay, as you plug in numbers that are bigger than c, let's say you keep following this curve right down here, and it looks like from both sides, and it is in fact from both sides, that the y values are approaching. If you think about it along the y-axis, are the y values approaching one number? And yes, in fact, they are. So if the y values are approaching one number as the x values are approaching the other number, then we have a limit, and the limit is n. Okay? So what I want you to think about, though, is one other thing. Okay? I want you to think about looking at the graph, because you might go, well, yeah, can't you just plug it in? Isn't it always going to be the same? Well, I'll show you in a couple more slides here that's not always going to be the same. But I covered up what is happening to the graph of y equals f of x at that specific x value of c. In other words, this view right here is kind of like the opposite of the in between the shutters of a window. Okay, in fact, let me do this. Oh, I knew that was going to happen. I don't know what this software. Hold on one second. Anyway, I'm not going to try to back up. This app kills me. I try to redo or undo what I just did, and then it puts something else up there on the screen. I don't get it. So anyway, I just got to work with it. So I was going to give you an illustration. Maybe I'll do that in class. But anyway, with your calculus eyes, I want you to be considering what happens here. I want you to try not to look at the graph when you're trying to find a limit. Try not to look at a graph using the same eyes that you always look at graphs with. In other words, you're used to looking at a graph using your algebra eyes. Okay, in the algebra eyes, you're just trying to figure out what is happening at that value of c. Well, your calculus eyes, you're trying to figure out what is let me see here if I can move this around here. Okay. Calculus eyes, you don't care what happens at c. What you want to know is what are the y values approaching as x values are approaching c. Okay, now that key word is approaching because you don't have to get there for you to have a limit. Alright, well, you might be totally confused right now, but be patient. Let's go on to the next. Okay, so here's the next slide. Do a couple limits here. What is the limit of x squared, y equals x squared, as x approaches 2? So when we plug in real numbers, it might seem really a lot easier. So as x is approaching 2, and let's do that in the same colors here. Okay, so x is approaching 2. The y values, follow along here, these y values are approaching 4. And so we say the limit is 4. Okay, well, as x is approaching 3 for the second one down here, we have 1, 2, 3 right here. X is approaching 3, and well, what value is that right there? Well, you might be thinking, well, all you have to do is plug it in. Well, in this case, you're right. 3 minus 1 is 2. And so the point right there has the coordinates 3, 2. So the y coordinate is 2, x coordinate is 3. So the limit as x approaches 3 is equal to 2. Limit of x minus 1, because that's what the function is, y equals x minus 1. That goes right there. Okay, that is f of x. Okay? And so those are two pretty easy examples. We'll look at some a little bit more challenging. Okay? Now, here's two examples like what I was saying. I want you to be looking at when you're trying to find the limit of a function. Uh-oh. Did it reset? Well, I don't know what's happening. Like I said, this is new software, so maybe I'm kind of messing up here. Let me back up on this one.
What is that?
No.